Hello, Internet. Today's project is the making of a tabletop Christmas ornament. It is a very abstract depiction of the Nativity family, showing Mary holding the baby Jesus, with Joseph standing by with a shepherd's staff. The Star of Bethlehem is also included overhead. The material is solid cherry wood. The ornament size is 15 inches tall, 11 inches wide, and 1.3 inches thick. As always, the project starts in Fusion. This is a sketch of the part. This is based on an ornament that I found on the internet. I am not the originator of this design. The sketch is turned into a 3D model with an extrusion. I extruded it down from the plane of the sketch 1.3 inches. That corresponds to the 1.3 inch thickness of the stock. My problem is my machinery and tooling will not allow me to cut all the way through 1.3 inches of material. So in order to build this part, I need to cut it in halves. I cut the top half from the top, about a little more than halfway through. In fact, I go through 0.7 inches from the top. Then I have to flip it and cut the rest of the part from the bottom, the final 1.7 inches to get the full 1.3 inch thick part. The problem with doing that is keeping my tool pass for the top aligned with the tool pass on the bottom. And the solution to that problem is alignment holes and alignment pins. In order to precisely place alignment holes, I added to the model the material that surrounds the part itself, and in that material I placed three alignment pin holes. These three holes are actually milled in the top of the part, as shown here, and then the mirror image of these three holes is milled in the spoil board. Then pins in these holes can keep the stock aligned when I flip it for milling from the bottom. And in so doing, I will be able to precisely locate the partially completed part when I flip it and know exactly where the already milled pockets are for purposes of milling from the back. Here we're using a 20-degree V-bit to precisely locate the 0 point on the spoil board. Now we're cutting the alignment pin holes in the spoil board. We're using a 1/4 inch bit to make the three 5/16 inch holes. These should be a mirror image of the holes that will be made on the front of the part. Now we've mounted the stock and we're running the first tool path using the 20-degree V-bit to engrave the bottom of the ornament. Now we're using the 1/4 inch end mill to mill the alignment pin holes on the front of the part. These are the mirror image of the holes that we just milled in the spoil board. Now we're starting the actual milling of the part. We're using a 1/4 inch end mill to mill the pockets in the part. I'm using for the first time my new Onefinity dust shoe, but at this point I realized that it will work better if I turn on the dust collector. Now we got the dust collector running. thus is a little more under control. The pockets look pretty deep, but they're only 0.7 inches deep, done in several layers. It's about halfway through the material. Now that since the 1/4 inch end mill was already mounted, I went ahead and used it to do the top half of the contour outline of the entire ornament. And it also, of course, is done in several layers. Now that the 1/4 inch runs are done, I'm using a 1/8 inch bit to refine the pockets and smooth over the surface left by the 1/4 inch bit. This is actually a spring pass done so I could show it without the dust shoe obscuring the filming. The 1/8 inch bit is required to get the full contour of the pockets outlined. Now we're using the 1/8 inch bit to refine the final contour cut. Again, this is actually the spring pass, so we could show it without the dust shoe obscuring the filming. And that completes the machining of the top of the ornament. And here's how it looks so far. And it's time to flip the part. First, we will insert the alignment pins in the holes in the spoil board. And flipping the part will align the part so that its 0 point will precisely match the 0 point when it was flipped the other way. And we start off again, as we did in the front half, with a 1/4 inch end mill to do the rough outline of the pockets. And it's cutting the pockets from the back, also in about 3 steps. Now in this pass, if we look closely at the bit through the transparent dust shoe, at some point we'll actually see the breakthrough from the top half to the bottom half. And there it is right there. We're breaking through so that the two halves are coming together. And there is the part after the 1/4 inch is done. I then use the 1/8 inch to do the final refining of the pockets from the back. Again, this is actually the spring pass, so we could show it without the dust shoe. That completes the pockets on the interior of the ornament. We now move to the 1/4 inch bit, cutting the final contour of the overall project. Again, We're doing it in several elevations. This is the first elevation. Now this is the final elevation, and we'll get a glimpse of the holding tabs. There's one roughly in the center of the shot. And now this is the final tool path for the project. A 1/8 inch spring pass around the final contour of the back half of the project. Now we're done with the CNC work. Takes a little doing to get the alignment pins off the project. Project is still captured in the stock with 9 different tabs. Tabs are pretty robust, and they are holding it firmly against the stock. To remove those rather robust tabs, we had to use a flush cut saw, and I'm just going to show a couple of them being cut here. As I said, there were a total of 9 tabs holding the ornament within the stock. Next machining task is to remove the stubs of the tabs. Here we're using that flush trim bit in a traditional router table. And we're just running that against the contour of the part to remove those tabs. And final step is using Rubio Monocoat to rub on a hard wax finish to complete the project. Thanks for watching.